we're going to go through the notes for 3.1 in Chapter 3. So initially it tells us that we're going to identify pairs of lines and angles. So here's some vocab. Parallel lines. They are coplanar lines that do not intersect. So here's an example of two coplanar lines that don't intersect. So coplanar just means in the same plane. So think about these as like railroad tracks. Railroad tracks will go on parallel to each other, but they will never intersect. Okay, skew lines we'll do more in class, but they are lines that do not intersect and are not coplanar. So they're not in the same plane and they do not intersect. For right now, just get the notes down and we'll do this together in class. Parallel planes. They're planes that do not intersect. Anything that's parallel is always going to be the same distance from its partner, and they will never cross or intersect. Okay, a transversal. So I'm just going to slide this up for a sec. Okay, a transversal is a line, so it's this line right here. So it's this one right here, and it crosses two other lines. So here's a line, here's a line. Now technically I should have put arrowheads on them, and you can add arrowheads to yours, but this is a transversal, and these are the two lines that it intersects. So a transversal by definition is a line that intersects two or more coplanar, the same plane, lines at different points. So here's my transversal. Right here is where it intersects the first line, and then right here is where it intersects the second line. Okay, here are some postulates. These are statements that don't need to be proven, but they're going to help us understand some of this geometry. So a parallel postulate, I'm just going to slide this up again because I think I have some sketches down below. Okay, so this is what it says. If there is a line, so here's a line, and a point not on the line, meaning not on the same line. So here's your line, here's your point. Then there is exactly one line that I can draw through that point that will make these two lines parallel. Okay, so you start out with a line, you then put a random point below it, and then it's telling us that you can only put one parallel line through that point. So it's parallel to the line above it, and it goes through that point. And that's called the parallel postulate. The second postulate is the perpendicular postulate. And that's saying the following. So fill in the words line and point and one, and then I'll give you the demo down here. Okay, so if there's a line, so here's the line right here. All right, and then there's a point not on the line. So here's this red point. Then there is exactly one other line, which is right here, that can be drawn through this red point and perpendicular, see the right angle, to the line we started off with. Okay, you may need to just go back and think about that, but that's what our perpendicular and parallel postulates are telling us. Okay, so let me go down a little bit further. We're going to the second page. So here's some examples. Sometimes examples make things clearer. Identify relationships in space. So which lines or planes in the figure appear to fit the description below? So lines parallel to line CD. So where's CD? Here it is, right along the side, and containing point A. Well, here's point A. So this line right here, line AB, is parallel to line CD, and it contains point A. So I'm writing it AB with that line symbol on top. Okay, lines skew to CD and containing point A. So here's CD. Now, skew means it can't be in the same plane. Okay, so this is a plane right here. The blue top is considered a plane. Here's point A, And this line right here, AH, that is not in the same plane, and it's never going to intersect CD. And that's what a skew line is. So the line I want is line AH, which I did in red. Okay, the next thing. Where are the lines that are perpendicular to CD? So here's CD, and contain point A. Well, do you see this little red box? That's the perpendicular box. And look, this line right here, AD, has point A and is perpendicular to CD. So the line I want is line AD. All right, and as I said earlier, you may need to go back through this to make sure that you're getting this. Okay, planes parallel to plane EFG. Okay, so where is this plane? EFG is the bottom of the box. See right in here? That is plane EFG. So I want to know what's a plane that's parallel to EFG and contains point A. Well, parallel means that they look like railroad tracks. So I think this plane up top here is parallel to this plane here. So I can name this plane lots of ways. I need 3 letters, not in a row. So I can call it plane CDA, or plane DAB, or plane BCD. There are other ways to name this as long as you have 3 letters not in a straight line, and there's some of these 4-letter options that we're looking at, and you mean this plane, you are correct. Okay, so think about that. Okay, example 2. Example 2 is going to have us look at this map. This is a map of Niagara Falls. Okay, so here's the falls over here. You can see the rim of the falls right here. Then they put some roadways over here for us to analyze. So it says name a pair of parallel lines. So parallel are lines that are not going to cross ever. Okay, so what's parallel? Oh, another thing to note. See this little symbol? The arrow, and this arrow, and this arrow? Make a note of that. That means parallel. So this line right here, DM, and this line right here, EF, are parallel because I can see I have the double arrows. And that tells me they're parallel. Okay? So when I write this down, here's my line DM, here's my line symbol. These 2 lines on a slant, so these 2 lines on a slant, they mean parallel. And then here's my other line, EF, with the correct line symbols on top. Okay, so you've gotten pretty good about recognizing lines and using the notation. So I want you to keep being good about that. Okay, next thing. Name a pair of perpendicular lines in this picture. Okay, here's my right angle symbol right there. That's going to tell me that lines are perpendicular. So look at what I'm going to do. I'm going to find this line that comes down this way. It's line MD. And then this line that comes down this way, which is line BM. Those 2 are perpendicular, and this is the symbol for perpendicular. So line MD is perpendicular to line BM. And you should make these illustrations on your work as well. So next thing, is line FE, so where is that? Oh, that's right here, parallel to line AC. So look, here's FE or EF, here is AC. Now, I see what's going to happen here. This line's continuing. It is going to cross this line EF. The second you see that's going to cross, you know the lines are absolutely not parallel. So you would say, no, they are not parallel. Okay, so then we have these key concepts. We're going to work with transversals. Remember, a transversal is a line like this that cuts two other lines. Okay? And there's important features about this. There's a lot of words involved. So here are some words. Angles that have corresponding positions. That means it's the same address. So let me show you how I'm going to do this. Do you see that this red star is located to the right of the transversal and above a line? This red star is also located to the right of the transversal and above a line. They have the same address. They are corresponding positions. Look at the blue and the blue. Both of these blues are located to the, hopefully I said to the right. Okay, the reds were located to the right of the transversal and above the lines. The blues are located to the left of the transversal and above the lines. Same address, they are corresponding angles. The gold angles are located to the left of the transversal and below the line. That's corresponding. The black stars right here are located to the right of the transversal and below the lines. Those are corresponding. They have the same address. If you think about me taking these four stars and picking them up and putting them down here, do you see how they'd be in the same exact positions? So think about that. Corresponding angles, corresponding positions is what I want you to know. Okay, now let's look at this picture. I have a transversal. This is the red. I have two lines. The angles that lie between the two lines on opposite sides of the transversal are called alternate interior angles. Okay, these are inside in the shaded area, and they alternate on either side of the transversal. Those are alternate interior angles. Okay, we've got two more. Okay, alternate exterior angles. Look where I shaded. I shaded outside the place, so they're not between the lines, they're outside, they're exterior. So they alternate, the green alternates with this green. They're on opposite sides of the transversal. The blue alternates with this blue. Those are alternate exterior angles. Then one last one, consecutive interior angles, also called same side angles. Inside again, see where it's shaded? Inside between the two lines. These reds are on the same side of the transversal, and these blue are on the same side of the transversal. Okay, so those are consecutive interior angles. So we need to know this stuff. So you may need to, rewind a little bit, go back and think about what I'm saying, and then draw these shapes for yourself and use the shading in. That's very, very important. Okay, let's try some of these. So we're going to make this a little bit smaller so we can have everything on one page. Let me slide this up. Okay, this says example 3, identify angle relationships. So you're going to identify all pairs of angles of the given type. So corresponding. So first off, I have to remember what these are. So you may need to be flipping back to the other page. But let me tell you about the shading. This pinkish shading are exterior shadings. The greenish are interior shadings. Remember, corresponding has the same address. So 1 and 5 are both above the transversal and above and to the left of the line. 2 and 6 are both above the transversal and to the right of the line. 3 and 7 are both below the transversal and to the left of the line, and 4 and 8 are both below the transversal and to the right of the line. Okay, they have the same address, they are corresponding. Okay, alternate interior. We're going to look inside where the green is. So 2 and 7 alternate on either side of the transversal, and so do 5 and 4. And that's why I have those numbers here. Alternate exterior. We're going to look where the pinkish ones are. Okay, so alternate 3 and 6, and 1 and 8. And the last one, consecutive interior, also known as same side interior. 2 and 5 are on the same side of the transversal, and so are 4 and 7. Okay, so we've applied the definitions that we've learned to these particular drawings. Shading is important. Okay, the next thing you're going to do is look at this homework. So your homework is going to be the next 2 pages. But go back, make sure that you understand these notes, make sure you take good notes on my notes, and also make certain that you use your shading and your color. It's very important. It helps you to understand the material and to be able to visualize it.